So we've created, we've explored, and we've interrogated our table. And now we're going to dive into indexing, slicing, and filtering. And where we'll begin is with lock. Now lock is used for label-based indexing. So what that means is that we can specify a certain column name that we're interested in and then get the corresponding rows within that column. So one thing to keep in mind though with this is that contrary to what you might know from Python, when we do slicing with PyKX, both the start and the stop are included. So just keep that in mind. So let's take an example. We want to get every row from our Bitcoin table from the close column. So here, all we need to do is say table.lock. We're slicing the entire table all on the close column. So we're going to get every single row from the close column. We run that, and as you can see, we do indeed return all of the rows in the close column. Now we can also do this not using lock, and here's just an example of that for your reference, just using square brackets to get all of the rows in the close column. So what if we want to apply some filtering to the rows that are being returned from this indexing? And how we can do that is relatively simple. All we have to do is take our table, we use .lock again, we specify table, the column within the table that we're interested in, so the volume column here, and we only want to return the rows that have a volume of over 100. And so we just specify greater than 100 as our filter, and when we run this, we'll see that all the rows in the table that are returned have a volume of greater than 100. Let's take another filtering example. So in this case, we want to return only the rows that match a specific date criteria. So here we're going to take our table.lock, specify the column that we're interested in here, so table of the date column, and we want that to be equal to the date atomic type of August 17th, 2017. So all we're doing is saying only return the rows where the date is equal to the specified date that we're interested in. So if we run this, we'll see that indeed all of the rows returned have a date of August 17th, 2017. Perfect. And you know, there's other ways to do this as well, not using lock. So we can try it this way, where we're just specifying only return the rows that match our date filter here, and we're just using square brackets in this method. Okay, so now what if we wanted to see, are there any rows where the ignore column is set to true? So in the original data set, we know that there's an ignore column, and it's a Boolean type. So we know that it's either going to be true or false. And let's look through every single row and ensure that all of the values there are indeed false. So we don't have to ignore any of them. So we're just asking, are there any true values here? And we see that there are not, which means that all the values are false. Okay, so go ahead, pause the video, try exercise 10, and check your work. Now, to index with integers, we will use integer position-based indexing, or ilock. And when we use ilock, we are returning the rows in the table based on integer positions. Now, an example of this is taking our table .ilock square brackets of the integer position that we are interested in. So in this case, the first row. But we can also do slicing with ilock, where we go table.ilock and pass in the slice of indexes that we are interested in. So in this case, the first 5 indexes. Now we can also do some filtering with ilock, just like we did with lock. So what are we doing here? We're taking our table .ilock, and we only want to return the rows where the volume is over 1500. So in this case, we say table.ilock volume column is greater than 1500 in a float, atomic type float. And we also only want to display the volume and the date columns when we run this. So if we run this, we'll see, okay, we can see all of the rows where our volume is greater than 1500, and it looks like that was filtered successfully. Okay, so we did some indexing, we did some slicing, a little bit of filtering. How do we sort a table? And we can sort tables using sort values. And this will sort table objects based on the values within a specific column. So say we wanted to sort our values to find the highest closing price at the top. So we really want this to be in a descending order from high to low. So we say table.sort values. We pick the column that we're going to be sorting, which is the close column, and then we choose ascending to be false because really we want this to be descending high to low. Let's run this, and we're able to sort this table effectively. And we can use PyKX native functions to do sorting as well, where we want to sort in an ascending order on the close column, tab BTC, which is our table, and this will sort it in an ascending order based on that close column. So you have all this data, and you might want to group it together in certain ways to apply operations on those groups. And to do that, we can use GroupBy. But before we get started with using GroupBy, it's often best practice to set a specific column in our table to be the index, especially a column that we're going to be grouping by, because this will make the operations that we apply to the table that much more efficient. So we're going to be grouping by date. So we're going to set date to be our index in this case. So now we've set this to be our index. We can see that date is in bold, just so we can visualize that's our indexed column. And now let's do some group bys. So first what we're going to do is take our table, .group by, and we're going to group our table by date. So if we think about the table that we have all these rows that represent 1 minute. And that's interesting and that can be useful, but what if we want to actually group all of the minutes per day together so we can do analytics on an entire day? And using GroupBy, we can do that. So that's exactly what we're doing. We're grouping all of the minutes within a specific date together so we can do those operations at a daily level. So what do we want to do with this? We can group it together using GroupBy date, and then we can apply an operation to that group. So in this case, we want to find the final closing price for each date. We can do table group by date dot tail of 1, and this is going to be grabbing the last index from that column, and we're going to be doing this on the close column. So what we're doing is finding the last price every single day within our table, and this will return to us a vector of those final prices at a daily level. Now let's take another example. Let's group by date again, but let's see what's the total volume for each day, because right now it's split up into minutes. We know the volume for every minute, but we may want to know the volume at a daily level. So to do this, we just group by date again, and then we're going to sum up all the values in the volume column for each day. And here we can run this and see that it will return the total volume for each date. And then when we're done, we can just reset the index, which means that the date column is no longer the index. And we do that by saying table.resetIndex.